Welcome to provide a solution to this nice algebra problem, which is a times b, which is 1. Let's call this equation 1. We have a plus b is equal to 1. Let's call this one equation 2. So the question is, what are the values of a and b? Now solution here, from equation 2, which is a plus b, which is equal to 1, let's make b the subject of the formula. That is b, it's equal to 1 subtract a. Let's call this equation 3. Now, let's substitute equation 3 into equation 1. So remember that equation 1, it's a times b, this is equal to 1. Let's substitute b. So the value of b here, it's equal to 1 minus a, and this is equal to 1. So now let's open the parentheses here. We'll have a times 1, this is a, subtract a times minus a, which is minus a squared, this is equal to 1. The next step here, let's take 1 on the left hand side so that we'll have a minus a squared, subtract 1, this is equal to 0. Now the next step here, let's rearrange this equation so that we'll have negative a squared plus a subtract 1, this is equal to 0. The next step here, let's make this as a quadratic equation. Let's multiply both sides by negative 1. So negative 1 times negative a squared, which is a squared, and then we have negative 1 times plus a, that means this is negative a, then minus 1 times minus 1, this is plus 1, this is equal to 0. Now this is a quadratic equation with a equal to 1, b equal to negative 1, and c equal to 1. So the next step here, let's check the nature of this quadratic equation by determining the discriminant value of this quadratic equation. So the discriminant value is expressed as b squared minus 4ac. So let's substitute the values of a, b, and c. So we have negative 1 squared, subtract 4 times a, which is 1, times c, which is 1. So this is negative 1 squared, this is 1, subtract 4, and this is equal to negative 3. So negative 3 is less than 0. Negative 3 is less than 0. So that means that we have two complex roots here. Okay, we have two complex roots here. And so for these two complex roots, let's apply the quadratic formula so that now we'll have a1, a2, this is equal to negative b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. The next step, let's substitute the values of a, b, and c so that here we'll have minus b. In our case here, b is negative 1, so it's minus minus 1, plus or minus the square root of b squared minus 4ac. And you find that b squared minus 4ac is what we have here, negative 3. So let's substitute here negative 3. All this divided by 2. The next step here, we'll have negative times negative 1. This is 1, plus or minus. Now, the square root of negative 3 can be expressed as 3 multiplied by negative 1. All this divided by 2. And now, we'll have 1 plus or minus the square root of negative 1. The square root of negative 1, this is I. So we'll have I square root of 3, all this divided by 2. So this means that we have two values of, we have a1 equal to 1 plus I square root of 3 divided by 2, and we have a2, which is basically 1 subtract I square root of 3 divided by 2. These are the values of a1 and a2. So let's solve the corresponding values of b1 and b2. Okay, so let's refer to equation 3. Equation 3 here is b is equal to 1 minus a. So let's solve as follows. Now from equation 3, we have that b is equal to 1 minus a. So we have a1 is equal to a half plus I square root of 3 divided by 2, and a2 is a half subtract I square root of 3 divided by 2. So that means let's determine b1. b1 is equal to 1 subtract a1. a1 is equal to half plus I square root of 3 divided by 2. So that means that b1 is, this is 1 minus a half, which is a half. Okay, this is negative times plus I square root of 3 divided by 2, and this is the same thing as negative I square root of 3 divided by 2. So that means that b1 is equal to half minus I square root of 3 divided by 2. So let's solve for b2. So b2 is equal to 1 minus a2. a2 is half subtract I square root of 3 divided by 2. And that means that b2, okay, this is equal to 1 minus a half, this is half, okay, then minus times minus I square root of 3 divided by 2, this becomes plus I square root of 3 divided by 2. So that means that we have that a1, b1, this is equal to half plus I square root of 3 divided by 2, and b1 is actually half subtract I square root of 3 divided by 2. So this is the first set of solution. This is the first set of solution, and we have the second set of solution as a2 b2, which is essentially equal to half subtract I square root of 3 divided by 2, and b2, which is half plus I square root of 3 divided by 2. So these are two sets of solutions. These are two sets of solutions, a1 b1 and a2 b2. So let's verify quickly that a1 b1 and a2 b2 actually satisfies the equation. So if you recall from equation 1, we have a multiplied by b, this is equal to 1. And we have that equation 2a plus b, this is equal to 1. So this is equation 1 and this is 2. So from equation 2, which is actually a plus b, this is equal to 1. So let's substitute the value of a1 and b1. a1 is half plus I square root of 3 divided by 2, okay, plus b1. b1 is actually a half subtract I square root of 3 divided by 2. This should give us a value of 1. Okay, so from here you can see clearly that I square root of 3 divided by 2, if you subtract I square root of 3 divided by 2, actually this simplifies. So that means that a half plus a half, this is actually 1, which is equal to 1. And that shows that a1 b1 actually satisfies the equation. What about a2 b2? So let's substitute a2 b2 quickly, so that we'll have a2 is a half subtract I square root of 3 divided by 2, okay, plus b2. b2 is a half, okay, plus I square root of 3 divided by 2. This should give us a value of 1. Again here we have negative I square root of 3 divided by 2 plus I square root of 3 divided by 2. So this actually simplifies. So in this case, we'll have a half, okay, plus a half, which is 1, and this is equal to 1. So that means that the left-hand side is equal to the right-hand side. And that also shows that a2, b2 actually satisfies the equation. So kindly follow the steps, like this video, and subscribe.